So this is talk about MySQL Tuner 2.0. Who here's used MySQL Tuner 1.0? Okay, great. So since most of us don't know, not responding. Really? Seriously?
Is it still written in Perl?
It is still written in Perl, but it's easy enough to change that to Python or something if you really wanted to. There we go. So MySQL Tuner 1.0 was basically just a quick sanity check. The author was Major Hayden, and I actually talked with him, and he said I could take it over, take the name over, whatever. Basically, it just looked at status and system variables like show global status, show global variables. It did the memory, the architecture. It looked at the memory, the amount of memory it had versus the amount it used. It looked at the architecture, were you 64-bit or 32-bit. It looked at the tables and table sizes and what kinds of table types you were, storage engines you were using. But not all the recommendations were relevant. For example, if you had the query cache turned off, it would say turn it on. Even if you turned it off on purpose because maybe you didn't need it, which most people don't. MySQL Tuner 1.0 hard-coded everything. What to check, the thresholds, what was recommended or not, and what the output said when it was recommended. So for instance, if you had something that had like a lot of sorts, it would say, oh, you're doing a lot of sorts, increase the sort buffer size. But that's not really what you want to do. Really what you want to do is find the queries and see if you can sort them better by using an index or something to sort instead of doing a second pass through it. Even though I said what to check is hard-coded, you can skip some checks, but not all of them. And there was no offline mode. So this basically, I started playing with MySQL Tuner because I wanted an offline mode. Because we had some clients who basically said, we just want a quick sanity check, we want you to look over like our variables and see if you can just give us some recommendations based on that. And so instead of actually looking through all the variables and whatnot, being able to run MySQL Tuner against them would be great, but we wanted to be flexible about what we checked. So MySQL Tuner 2.0 is still a quick sanity check. It's much more flexible though. It's guided by a configuration file. So you choose what you want to check, what the threshold is for a recommendation, whether or not you want the recommendations, and what the output is. And it can be remote, so you can run it on one system to check a database in a different system, or it can be completely offline. You can run it on a system without a database and without actually connecting to a database as well. So how it works, it is written in Perl. One of these days I'll probably convert it to Python. There's a bunch of his initial code that allows you to do things like use it with Plesk authentication, like if you have a Plesk system. And I haven't touched that. So, I haven't touched it because I haven't wanted to change it, but it still works. It works with Windows and everything. So I didn't want to have to change anything like that. So that's also why I haven't completely taken it over yet. And if you go to mysqltuner.pl or something, it's still the old version because I haven't gotten every of the features he had into it in, but most of the checks are there. It basically will get the status, it gets some information into a key value hash. Right now it will do show variables and show status. I've started to code it so that it will get sizes of tables on disk versus sizes of tables in the metadata, so you can check for fragmentation and stuff like that. But it's any key value pair. So right now it's just status and system variables. For example, the key is max connections, the value is 100, or at this point 151, I think, is the default. But it could be anything. It could be like a database and table name as the key, and then the size, the value is the size and information schema. There are many supported platforms, so whatever supported, whatever MySQL Tuner 1.0 supports, this supports. I've used it on Cygwin, but all the major, Solaris, Linux, CentOS, whatever, is all fine. It can get information from one or more files. So basically, if you have a key value pair in a file, you can just load in the files. And you do it with a -- file list and comma separated list there. But if you use file list, it's hard-coded to say you either do files or connect remotely. That's easy enough to check. You just change the if statement. But for now, I just kind of wanted an easy offline mode, so I did that. So what does the configuration file look like? So basically everything, most of the stuff is all config file parsing. So the configuration file, well, the pound is a comment. The delimiter is 3 pipes in a row. I actually like using a pipe as a delimiter. But as I went forward, I realized that the easiest way to use stuff was to let Perl just execute expressions natively. So sometimes you might want or in there, so you want 2 pipes. So I delimited it by 3 pipes. Because sometimes you have a quote, if you have a quote mark and you're using a comma or a semicolon, you don't want a comma, semicolon, or delimited. So that's just kind of my general delimiter. So 3 pipes. There are 4 fields. First is the label, which is always printed. For example, slow queries might be the label, or percentage slow queries, or rate of slow queries might be another one, or max used connections might be another one. The comparison in value, so it's what you compare, that's your threshold. And then the expression, which is how you calculate the number, the value, and the expression is always printed out. So that 13.25 is the result of the expression. And then the output, which is what will show if you want to see recommendations. So here's the config file. So here's the percentage slow queries entry, right? So you have percentage slow queries is the label. The comparison is greater than 5. So if you have more than 5% slow queries, well, how do you calculate that? Well, how you calculate that is slow queries divided by questions times 100. Now, the way that MySQL Tuner parses it takes the expression, so that's slow queries divided by questions times 100. It goes through your key value pair. It made this associative array, this hash of keys and values, and it goes through them, and any word that it can replace with a word in the hash, it then replaces it with the value. So when you do a show status and you load it into the Perl loads it into the hash, it'll just say, oh, slow queries. Okay, that's a word I know, and let me put the value in there for that. And then the output is too many slow queries, either increase long query time or optimize the queries so they're no longer slow. I forget what the output of MySQL Tuner said. It's either one of those two, or it was something completely different. But basically, sometimes you have you have a lot of percentage of slow queries because you're loading data in, so maybe you don't care. Or maybe it's an ETL machine and you have long query time set to 5 seconds and it should really be 30 seconds. So, or maybe you just have a lot of slow queries that you need to optimize. So that's where this kind of being able to be flexible about what's said too is very important. Now again, this is not kind of a DBA in a box product. It's just a sanity check. For people who already know what these things mean, it's a sanity check. It's to be able to say, what is this formula really quickly without having to do a show global status, what's slow queries and what's questions, and now divided times 100. This will do it for you. So it's not supposed to necessarily add any knowledge. It's supposed to use your own knowledge, but doing the math by yourself. So slow queries and questions are replaced with hash values. The expression of the value is calculated, the comparison is made. Now, one thing that's important is, again, because one of the reasons it's so flexible is because it's so dumb. So if you have a key value pair where the key is the slash, the divided by sign, you're going to end up having some really weird output. Now, why would you ever have divided by as your key? You wouldn't, but maybe you might have something like slow questions or slow queries as a different key, and you might end up overwriting that value in the hash. So you do have to be careful. So if the value is greater than 5 and you have the dash recommend option set, then you're going to see the output at the end. Now the comparison value and the expression are both Perl. So I don't know if can you guys see the supported version here? So basically the supported version, it takes the substring of version, it takes the first letter, the first character of version. If the first character of version does not equal 5, then what we would recommend if you have the dash recommend flag is version is less than 5.x upgrade. Now, you might have 2 of these. You might say, hey, if version is at 5, complain that's less than 5x. If the second character, right, so you say, okay, if you have this and you have the second character less than 1, then complain. Or in about a year less than 5, then complain that, hey, it's not 5. And here you're using not equals. I could have done less than. It doesn't really matter. It would matter if you're using, something like when everyone is in 5.5 in a year or so, it doesn't matter if it's 5.0 or 5.1. I guess you could say not equals 5 as opposed to less than 5, but anyway, the idea is it's Perl. So here's There are some functions that are hard-coded in MySQL Tuner that you can use in the expressions to compare. So from MySQL Tuner 1.0, you have pretty uptime, which is pretty much used for uptime. And basically, it takes a number in seconds and puts it to the right amount of days, hours, minutes, and seconds. And with 0 days, I think this one does, we'll say 0 days. But HR means human readable, so human readable number changes from 157,691 to 158K because this is kind of hard to read. MySQL Tuner 2.0 actually says thousands instead of K because it got confusing with M. I think it was using M for millions in some places and thousands and others, and it was just easier to say, hey, what I really mean is 1,000. But you know, it's Perl, you can change what it prints. And HR bytes, human readable bytes, again, this turns to K, or here actually kilobytes. So it's very clear when you say K whether you mean 1,000 or 1024. And I've added a few more. There's new functions, human readable by time, and that's for rates. So, you know, probably maybe 8 to 12 months ago, in the past year or maybe just about a year ago, there was a lot of discussion kind of among Planet MySQL where people were talking about doing rates instead of percentages. So for example, you know, we're talking about percentage of slow queries. Well, we really more care about the rate of slow queries. How many slow queries are increasing per second? Because if you had a lot of slow queries, you know, when you start things up, or for example, when you start things up, there's a lot of disk reads because nothing's in the cache yet. And so if you're looking at that kind of percentage, the percentage might be high because maybe you've only been using, you know, the database for 3 days. But what you really want is what's the rate that it's increasing at, because at first it's increasing at a very fast rate, and then it slows down because things are now in the cache. So there's actually a new function, HR by time for rates, and what it does is you give it a number, and that assumes that that number is already divided by seconds. So it's already in a number per second. So if you give it, so for example, HR by time, here's something that's actually a function. Slow queries divided by uptime. So it's going to be a rate of slow queries. So if you have 1,000 slow queries in the first day or so, but you don't have any more past that, your rate is going to keep decreasing, right? Because you're not having any more extra slow queries because the uptime keeps increasing. So if you give it something like this, it's going to translate it to, okay, 1, 2, 3, 5 divided by 157,961, which means that it ends up getting 0.078. Well, you know, if you have this, it's 0.078 per second. Well, is that good or bad? What does that mean? Well, this actually translates it to, when I can actually show you, it actually translates it to 4.69 per minute, which is much more readable to say, okay, now I understand. Because 0.0768 looks small. But 4 per minute is probably still more. You don't want a slow query every 15 seconds. That's a lot. So you might be fooled by saying, oh, 0.078, that's very little, I'm okay, but really 4.69 per minute. So how would you compare this? So what I've done here is you have this, so I've done this with sort merge passes divided by uptime. So sort merge passes is the number of sorts that cause temporary tables to happen. Where temporary tables may or may not be stored on the disk, but usually you want to avoid that. It basically has to do this extra pass so as to kind of create a temporary table for the results. So what I have here is the label is rate of sorts that cause temporary tables. The comparison is, does it match the word second or minute? Because back here I was saying, see it says per minute, so that would match minute. So if there's anything more than 1 per minute or 1 per second, it's going to show up here. So if you have 20 per hour, this won't flag it. But you can easily flag it by saying second or minute or hour. So it's, again, very flexible to actually figure out what you want to do there. And so you have, you know, I've divided by uptime since flush status, because if you flush the status, then the sort merge pass is going to be 0. So that's what that line would look like. And it's a little complicated, but once you kind of get the hang of it, it's pretty easy. And I like the fact that once you figure out in your brain, hey, you know what I want to calculate? I want to calculate max connections divided by, you know, max used connections times the BNODB buffer pool size. You could do that, right? And once you figure out what you want to do, it's really easy to implement because you just use the words that, you know, you just use the variables that you have. So what if you just want to print out a variable? You know, what if you just want to see what the size of the buffer pool is? You don't want to compare it or whatever. what I end up doing is I end up saying, like, so here's sort buffer size. If it equals 0 bytes, then the output is there's something wrong with the value of sort buffer size. But basically you just say human readable bytes for sort buffer size. And so the output here, as you see it, default is actually pretty format. So the other thing is you can change the output. So you can have it in pretty format, where it just has labeled colon expression, or you can have it in comma separated value format with sort buffer size, comma 4 megabytes. Now, you obviously can make your own module if you want it to go and insert into a database. You can have it do that. If you want to have it, be different delimited, you want to have it be tab delimited, you do that. Again, it's just a Perl thing. So everything's very modular, and to print stuff out, it's very easy to do. So this is what MySQL Tuner 1.0 looks like. I know it's very, very tiny. It actually looks bigger than this. I just wanted it all on one slide. So it starts with, okay, we logged in, we were able to log in. General statistics, yeah, we're currently running 5.137 or high, it's 5.1, so it's currently running the supported architecture. So that's running a 64-bit architecture, so that's good. Then it has some storage engine statistics. So basically, some of the stuff that's in this section is not yet in MySQL Tuner 2.0, but those are kind of the easy things to look at anyway when you're doing a quick sanity check. All of these performance metrics are in fact in there. Now you can see that it has some of these things are okay, and then some of these things say dash dash, and then some actually have exclamation points next to it. The dash dash is neutral. So for example, there's currently running on that, that's neutral. But there's okay, and then there's this is weird. So for example, maximum possible memory usage is 142% of installed RAM. Now this is one of these things that I actually didn't put back into the second version because the maximum memory usage would be if every single one of your connections for max connections was connected and using the buffer size and the sort buffer size, the join buffer size, and, every single temporary table memory. It just calculates everything. So if you actually have this being good, you're probably underutilizing your memory, which is not a good thing. So this is one of these things, and you can see like you can't really, here are recommendations, defragment your tables, reduce your overall MySQL memory footprint for system stability. That goes along with this 142% of installed RAM, because if you end up using more than 100% of RAM, when MySQL tries to allocate it, Linux will say, or whatever your operating system will say, no, we can't give you that, and then it will crash. So whilst the recommendation of, hey, you might not be stable, reduce your overall MySQL memory usage, there really needs to be a better formula for calculating maximum probable memory consumed. Like this is the maximum possible, in the twilight zone when everything's running at the same time, but that's not really the maximum likely. I mean, at first glance, the maximum likely would at the very least be taking max used connections. What's the high watermark for how many were connected at the same time, without even changing any of the what memory is calculated. But I would probably do some kind of like, well, what if 1/3 are using the join buffer, 1/3 are using the sort buffer? It's hard to say unless you know your system and you know what kind of things you're doing. So this is what it looked like. It's giving you a warning that the ENODB buffer pool size needs to be greater than 57 gig or equal to it, because that's how much there is in the ENODB tables. Okay, but this system has, or maybe it could have it, because it does have, looks like it does have 64 gigs of RAM. But I mean, if it were 100 gigs in the ENODB buffer pool, it would say, oh, it needs to be greater than or equal to 100 gigs, even though that's ridiculous. So a lot of these recommendations are kind of like, why are you giving these to me? These mean nothing. So this is what MySQL Tuner 2.0 looks like. This is the default with the pretty output. And this is the command I used on top. Perl MySQL Tuner --config with the config file. User, username, pass, my pass, or you can not put the username and password in the command line. That works too. And I did do -- recommend. And so it basically has here's uptime in seconds, uptime, questions, percent slow queries, 0, 0 query. I mean, the uptime is, was 1 day, so there were no slow queries. Here's the log query time. So again, we're putting out this variable and it's 1 second, which is, I think this was just on a test system or something anyway. But, it's useful if you have the slow query rate of, 5 per second and your long query time is 1, or your long query time is 0 because you want to log everything. That's important to know. Or if your long query time is 10 seconds and you have, 1 per second, one slow query log per second, that's a big deal. So I found that, when I was doing things like the rate and the percentage, it was more important actually also to know what the variable was set to, because I wanted to know it. So that's one of the ways in which this isn't really a DBA in a box. It's not going to be a DBA for you. It helps you just look at these calculations. One of the other things you can see, there's a lot of stuff, supported version 5, released series 5.1, minor version 37, and these are checking things. Minor version isn't checking, it's just printing out. There's actually 2 distribution checks. One checks to see if it's from like a third-party distributed vendor, and one checks to see if it's like a community version or not. You can take all these checks out as well. Percent query cache use, query cache efficiency, sort rows 8.18 per hour, that's okay. Total sorts 3, percentage of source cause temperature table, rate of source cause temperature. So there's a lot of rate here where there were percentages and other things. Here's another rate of table open, 47.86 per hour. Because again, percentage of table open, you're going to have a lot when you start it up. So the rate that, hey, there were 47 per hour, well, that's only been up for a day, almost 2 days, not even 2 days. So that's what that looks like, and you'll see the recommendations here. So there's still some more here, some from the bottom. And here are the recommendations. They kind of, there are full sentences here instead of what you saw before, which was just like, buffer pool size greater than or equal to 57 gig. Here it actually explains some things. So for example, the key buffer percentage used is too low. Because, do I have it here? Percentage of, no, I have it back here. The MySQL key buffer size is 150 megabytes, but the percentage of key buffer used is 29%, and the maximum, the high water mark is 11. So at most you've ever used like 30%, even though it's only 150 megabytes, it's saying, hey, it's used low. You may need to decrease the size of the key buffer size, or re-examine your tables to see if maybe you had indexes removed, so they're not being stored there, or examine queries in your expectations about when indexes are used. Because if you set that to be 150 megabytes, theoretically there's a reason, right? Why did you set it that way? Well, because you knew you had 150 megabytes worth of indexes, or maybe you had 100 megabytes worth of indexes, but certainly would you set it to 30%. So, try to give more default to useful values. In the end, people still use it as, I don't know if my MySQL Tuner is okay, if my MySQL setup is okay, so let me run this and it'll tell me if it's okay or not. It's really more a tool for an established DBA to say, I just want to do this quickly. Now the other neat thing is, the config file comes with all of these things in it. If you want to check one thing, you can. You can run it via cron, via cron script. So you could run it once per second, once per minute, once per hour. You can, have it give output into RRD format if you want. You can do all this stuff with it, and it's very powerful and flexible because it's very simple and done. Now, that being said, there are limitations. So what are the limitations? There's no grouping in output. Before you had like the performance metrics and things there. It would be nice to have a little section of my ISOM so that you could say things like, hey, here's all the MySQL stuff grouped together, or even better, if don't check my MySQL stuff. I know I'm only using it for the system tables, so don't check MySQL because I'm not using it. You might still want to know, and you check one item at a time. So for example, when I was saying before, you're checking to see if it's 5 and then 5.1, I could combine that into one check. But there are some things where you might want to say, look, check to see if ENODB is enabled. If it's not enabled, don't bother to do a check for the log buffer size for ENODB, because it's not going to be valid. I mean, you might want to check for one and say, okay, give this output, but then skip these next five checks. You can't currently do that. I mean, you probably could come up with a Perl expression to do that in a very long one check, but it's not really feasible and easy to do that, at least not right now. But the item is a Perl expression, so because of that, I don't know why I came up with this phrase, limited configurable logic flow, which basically means you can't say, if ENODB is not enabled, skip these 5 checks. That's the logic flow and it's configurable, but it's limited. And it's still not a DBA in a box. If you don't know what those numbers mean, the recommendations might help you, but those are just what I put down, so it might not be proper for your environment. This is a README file. Again, looks a little long, but I think it's pretty useful. because this is a README file, and this shows you how to use it. It has all of the things. It has very quick, if you just want to, there's a default config file in this package to use it, run MySQL Tuner.pl, config to your default CNF. It'll ask you for a username and host on command line. And so there is kind of this quick guide right here, like, oh, I just want to use it, let me use this, and then here's all the options and how you can do it. So basically, you can use force mem, force swap, and force arch to feed it the architecture, amount of memory, and amount of swap, so that you can use it in offline mode. You know, you can also put things into text files and use -- file list, as we have here, and then host port socket user and path. So it's, you know, again, very, very simple, very, very limited. So how to get it? If you really liked MySQL Tuner 1.0, which again is, you know, it's a decent tool, and you know, if you're a DBA, you know what everything means anyway, then you're fine. But it's hard because it doesn't tell you what the thresholds are for things like slow queries. So I had to go digging into the source code to see it myself. But it does have a very neat thing where you can just say wget MySQL because he owns the site MySQL and it happens to be a Perl script which then automatically downloads. MySQL Tuner 2.0 is a Launchpad project. Launchpad.net MySQL Tuner. The project is open up contributions, bugs, ideas. If you want to port it to Python, you know, I mean, it's not that big of a file. And MySQL Tuner name is used with permission, and I do have permission to take it over if I really want to, but I've been busy doing other stuff. So here's the Launchpad page, Launchpad.net MySQL Tuner. You know, you can download the latest stuff here. And that's the last slide. If you'd like, we have about 10 minutes left. I'm happy to take questions, or if you want to see it, I can download it and show you what the config file looks like. There's actually 2 config files. There's one for pre-MySQL 5.1 and one for 5.1 and up, because the variable names change. So you end up getting null Perl expressions, and there's not a lot of error checking yet, so you end up getting like a Perl error that it doesn't understand. Because if you have something like table cache, but the name of 5.1 is table open cache, and you do show variables, it's going to say, I don't know what table cache is, because it's not anything that I can do an expression with. So, are there any questions? Comments? Feedback? It's great. It's not, I just came in this room to hack quietly. He's ported to Python. Wait, was it Python you wanted to port it to? Or?
Yeah, something besides.
Yeah, Python it's such an easy language, especially to connect it to MySQL. It's really, you know, I mean, it would be trivial, and you know, porting stuff from Perl is kind of trivial, especially the Perl that I write. I write very simple code. I'm not a developer, right? So I'm not writing huge algorithms and whatever. And you know, part of the reason that I'm having Perl just evaluating it is, well, I could write all this API into it, but you could just use Perl's inner logic, and it would be the same with Python. You use Python's inner logic. So, okay, great. Do you guys want to like see the config file, or you pretty much got a handle on it from examples? You want to see it? I think I downloaded it. Let's see. Let's see where it ended up. Oh no, I didn't download it. Yeah, no, I was just looking because I knew, like, I used to actually use this, so I figured maybe I had an older copy of the thing, but I don't.
So the output you generated, you showed was generated using the default config file, right?
Yeah, complete default config file. The green and blue is just something that I was playing with to make it easier to read. I was trying to kind of group it to show people, but it doesn't come out blue and green. But yeah, I mean, and it doesn't look like this in 2 columns. It's just a very long column or whatever. So the first line, you know, says uptime in seconds, and that doesn't have, you know, just says uptime, and this has the pretty uptime one, and this just says this is a number of questions. The percent slow queries is so slow query is divided by questions times 1,000. This is divided by uptime. Like all the rates are divided by uptime since flush status. So, I mean, the formulas are not very, temp disk rate, 1.72 per minute, temp table rate, 12.84 per minute. So again, from that I could probably even do calculations of what's the, what's the percentage of, temp disks that go to table, at the rate of all that stuff. The rate of the percentage change as we do all that stuff. So anyway, I think everyone here probably knows how to reach me if you have questions, but it's outfief@gmail.com or shiri@palinodb.com. It's probably easier to remember, but thank you.
Thanks.
Sorry about the technical difficulties.